Hello, I will explain my data mining project codes. First, I will focus on k-fold code. This function is k-fold cross-validation code. It simply cross-validates the data n underscore split times. First, I converted my data to NumPy arrays. Then I started shuffling my data by creating random indexes using NumPy random choice. Then I created my new data with these random indexes that I create. Then I divided my data into 5 using NumPy array split function that I created for different empty lists. Actually, not 5, this is parametric and underscore split. And then I created different empty lists and assigned them as follows. Each list is the weighing dataset, each of them of the dataset. This for loop simply works as it adds the ith piece to the ith element of each test set by train and add the rest to the train set. This algorithm continues for the number of splits. Eventually we have as many datasets as the number of splits and returns to our datasets splitted as trains and tests. Calculate accuracy function calculates accuracy. If the predicted and actual labels are the same, it increases the correct value by 1 and returns the correct value divided by the length of the labels and returns accuracy. Compute mean and STD computes the mean and standard deviation. The average is calculated by dividing the sum of all numbers in the data by the number of data, and standard deviation is calculated as the square root of the variance, and variance is found by subtracting all the data from the mean, squaring it, and dividing it by the number of samples. The random function transforms the data by subtracting the mean and dividing by the standard deviation for all values. Apply z-norm function applies the z-norm using the compute mean and std function that I wrote and returns new data, transformed data. Covariance function implements the covariance formula. It subtracts x values from the average of its cluster and the a values from the average of its clusters and multiplies them together, applies this to all data and adds these values and divided by the number of samples. And correlation coefficients finds the correlation coefficients of two data, which is two column. It finds the mean and standard deviation of the relevant data using the compute mean and std function that I wrote, and then calculates the covariance of the data using another function covariance that I wrote. This is my function covariance, and returns the covariance over multiplying of standard deviation of x and y. This is a covariance coefficient. Correlation coefficient. And correlation matrix function takes all the data and calculates the correlation matrix for both values, not both for all values. And correlation coefficient function using correlation coefficient function calculates correlation matrix and returns correlation matrix to see which data is correlated another one or not. PSA function calculates the mean of each feature in column X, which is in this for loop, and the mean is stored in mean list. The original data X is copied into time to prevent modifications, and and the mean of each feature is subtracted from each data point to center the data set and center the data set, and using nplinalg.svd us and we represent the left singular vectors, singular values, and right singular vectors respectively. These principal vectors are contained in y. The function calculates the explained variance for each principal component using singular values. The vector list stores the principal component vectors. These vectors define new axes in the transformed phase and returns mean, width, and vectors. And apply PC finds the new transformed data using this PCA function. And using this PCA finding mean, weights, and vectors and prevent the modifications, we use temp. And the mean of each feature is subtracted from the data to center it, the data. The principal component matrix converted the NumPy array to some process, and transpose vectors of transpose is calculated, and getting n components from these vectors and multiplying with temp and finding the new transformed data components selects the number of components. Logistic regression class as an attribute, which is learning rate, number of iterations, weights, and bias of class and classes of the dataset. Fit extracts fit function extracts the number of samples and features from X, finds the unique class labels and stores them in self.classes. Initialize self.weights and self.classes, self.weights and self.bias with random values, self.bias initialize it with zeros, and applies the sigmoid function to get all probabilities at the end for prediction. And this for range for loop computes the gradients for optimization. Derivative of weights is 1 over samples. Derivative of weight is 1 over samples. Dot y predicted minus 1 hot encode labels transpose and x, and derivative of bias is 1 over samples dot sum of y predicted minus 1 hot encode labels transpose. Then updates parameters using learning rate with respect to derivatives of weights and bias, which is the v and dv calculated by these lines and explained a second ago. Predict function computes the linear model using learned weight and bias, and applies the sigmoid function to get probabilities, and using np.argmax to get highest probabilities in these predicted classes, and returns the actual class, which is highest probability. Sigmoid function computes the sigmoid to map values between 0 and 5, calculates by 1 over 1 plus e power minus x, and this logistic regression runs with one order all approach. One hot encode converts categorical class labels into hot encoded vectors, which is represented by numbers, not strings or anything. Fit labels, it's the same thing as one hot encode. This is generalization of the function for other other machine learning models. Test with logistics function. Test with logistic functions calls the function kfold to split the dataset into kfolds and loop through each fold, extracts training and text set, fit trains the model and predict or gets all the probabilities, calculate accuracy, calculate with respect to predict the and y test, and append the accuracies, list the accuracy for each fold. After all that, getting mean of the all accuracy to get average accuracy. After all of the process, printing the average accuracy of this k-fold with logistic regression. Combine sets function is designed for example, I need a place to store the final merged set, so I initialize empty, call it combined set. This for a correlation matrix for eliminating the find, for example, we can find A, B, and B, C correlated, and this concatenate the as a B, C into one set. To process all the given sets, I used looped. This way I could handle each set one by one. Since the input might not always be in the set format, I made sure each element was converted into proper set. This way I could use set operation without errors and look through all existent merged set. If current set shared element with any existing set, I merged that using update. I set merged equals true and stopped further checks. Bit break. If current set didn't merge with anything, I added it as a new set in combined. This ensured that non-overlapping sets remain separate. And returned combined, which is one list, all the correlated or non-correlated features, and use it in finding the correlations. Reduced positively correlated feature, and I loop through each pair of features in the correlation matrix. If two features had a correlation above the threshold, I stored them as a pair of indices in positively correlated features. Sometimes multiple features from chains of correlations, I use combined sets to merge these into distinct correlated feature groups. If no features were highly correlated, I returned the original dataset unchanged. I extract the column names corresponding to the correlated feature indices if positively correlated feature is obtained, and correspond to the correlated feature indices. These are correlated feature names and correlated data, and apply the PCA for correlated data to reduced data dimensions into the one-dimensional area, because all of them is correlation and all of them representable as one-dimensional area. For example, 3 of columns or 4 of columns or 2 of columns. And I merge the PSC reduced features back into datasets, and resetting the index ensure the proper alignment before concatenation. Reduced negatively correlated feature, same as the function with reduced positively correlated feature, but this function finds the under minus threshold values negatively because of test with AutoBoost function int. I initialize AutoBoost from Seikile sklearn that ensemble from Adapose classifier model. I train model on K dataset, which is K-fold. I trained on K dataset and predicted and getting accuracy for all of the Adapose classifiers and all of the K-fold datasets. I compute accuracy for the current fold using calculate accuracy and append the accuracy into the accuracies list and getting average of all accuracies of which is K-folds accuracies means and printing the accuracies with this and test with support vector classifier function. Initialize the model with configurable kernel parameters for trying different kernels and same as other test methods using k-fold getting all predicted calculated accuracy and uh, keeping accuracy in accuracies list and getting mean of the all false accuracies and printing the message. And this last functions for outlier detection, Mahalanobis outlier detection function. It calculates the cofactor matrix as a functions and calculates cofactor matrix as a inlier function and cofactor matrix of this calculated by cofactor matrix constructed by computing the cofactor matrix actually which is necessary to compute the inverse using the adjugate matrix formula. The cofactor matrix is constructed by the computing the determinants of all minors and applying the sign chains and which is mean vector is calculated by averaging each feature column across all data points and covariance matrix is computed using the formula that multiply x minus mean of covariance. This is covariance matrix multiplying by diff transpose dot diff over number of samples minus 1 and using np.lin calculating determinant of this covariance matrix and using inlier function that is cofactor matrix. Using that we find the cofactor matrix of this covariance matrix and adjugant matrix is transpose of covariance matrix and finding inverse covariance matrix this formula like adjugant matrix over determinant and I want to keep inlier indexes in and return them, so I created empty list for keeping inlier indexes and outlier is which is greater than this threshold and inlier index which is lower than this threshold and the distance is calculated by squaring this dot production this dot production is diff transpose and inverse covariance matrix and diff matrix. After all that squaring that getting the distance over two data points which is high dimensional data and getting inlier indexes lower the threshold which is over the thresholds and returning inlier indexes and these are my results. of different parameters and models. Design result different parameters and models, and design my result of correlation matrix, and design my results with different parameters and models. After the all processing done, we can see the accuracy is increased, and this is visualization of accuracy. Of course, more tables and images provided on report. Thank you.